Okay, it's the annual rate of decay, and it's going to be in decimal form. Okay, this whole thing, the 1 minus r, is going to be your decay factor. Okay, remember, if this is 1 plus r, it's called a what? Growth factor. So again, it's real similar to that. And then A is the original amount. And it's just a matter of plugging in the pieces where they go. Okay. Buy a car for 10,000. Guys, and let's say its value decreases by 16% annually. Okay, now, is your car ever going to be worth zero? I mean, as long as it kind of runs, as long as it works, you could probably sell it for something, right? Even if it's $1. Somebody would buy a car for $1, even if it doesn't work. Okay, so that's kind of where exponential decay, you can model that. So as it gets closer and closer to zero, guys, it's never actually going to equal zero. You'll always have some value in it, but it gets smaller and smaller and smaller as you continue to increase. So let's say it decreases by 16%. Okay, what is it worth? If you sell it or trade it in 8 years. Okay, so I want you to see if you can find that, please. And so the value of this car is going to be our original amount, 10,000, times 1 minus our percent in decimal form, so 0.16, all to the t. So now when I plug this in, I can substitute in the 8 for the t here, and so I can just evaluate it. So 10,000 times the quantity 1 minus 0.16, all to the power of 8. And it's in decimal form, so I can hit enter. And it looks like it's worth 2478.76 as its value. Okay. Now, the other way that you might get a question like this is just like what we did in the other examples. What if instead of this I asked, in what year will it be worth half of what you paid? Okay, so I want you to see if you can find in what year is the car worth half what you paid? You think you could just add 16, see how many times it takes 16 to get to 50? Now remember, the decay or the change happens exponentially. It doesn't happen cumulatively. So you can't just add it and say, well, after 4 years or after 3 years or whatever, it's going to be 50%. So you actually have to calculate it through. All right, so we're still using this equation, right? This model is true for any situation involving this particular car and this decay, the rate of decay. Okay, so we still use this equation, but now what we can do is we can use the solve feature of our calculators, plug in the equation with the new value. Well, if our value is just going to be half of what you paid, if you started with 10,000, half of that's going to be 5,000 is equal to 10,000 times 1 minus 0.16 to the t, and then just solve for t. Okay, so if we calculate that, we'll use our solve feature. Okay, so we type in our equation. 5,000 equals 10,000 times the quantity 1 minus 0.16, all to the t. Solve for t. And then figure out our answer is 3.9. Okay, or again, in this case, the 3.98 approximately. So in how many years will it be? Or I guess this would be in how many years? So it would be in almost 4 years. So about 4 years into it, it'll be worth exactly half of what you paid for it. Yeah. Well, in this case, I wrote in how many, because I didn't give you a date. If I had said you bought a car in 2000, your answer would be 2003, okay, or it would be the end of 2003.